Hello friends, here the computer network class. Now today we will learn networking devices. In OSI stack there is a 7 layer and each layer and some layer have networking devices. So we will learn all networking devices here. In physical layer there is a network devices called layer 1 devices having a repeater and hub is the example of physical layer devices. Now the data link layer called layer 2 devices and the example of layer 2 network devices are bridge and switch. The network layer devices called layer 3 devices and example is router. And the application layer devices called layer 7 devices and example is gateway. Gateway is a protocol converter devices. Now here the repeater is a layer 1 device and which is used in physical layer. Okay, it is a 2-port device. In repeater there is only 2 ports, one incoming and one outgoing. The repeater is used to amplify the signal, amplify the incoming signal, amplify the upcoming signal and send to the output link. Here when there is a long distance or channel distance is long, so that when the signal after some distance traveling some distance the signal become low. Signal become low due to the noise and other things. So that to amplify we use repeaters so that signal won't demolished at before the receiver end. So that the signal is won't demolished or this before the reach to the receiver end, so that repeater is used to amplify the signal so that it can travel more for the distance to reach the destination host. Okay, it amplify or regenerate the signal by taking 1 bit of the upcoming signal and taking 1 bit, amplify it and send it. Taking 1 bit of incoming signal, amplify it and transfer it. It is a 1 bit delay. It create 1 bit delay between the channel. In channel it create a 1 bit delay because it processes only 1 bit at a time. So it processes 1 bit, transfer take 1 bit, amplify it, transfer, take 1 bit, amplify it and transfer. It work with 1 bit only. So here the example, there is a host and the destination host. Between them there is a repeater. Okay, so if we do the round trip time or end-to-end delay, then there is a transmission delay, the packet transmission delay, then the TP packet sent to the repeater, then there is a 1 bit delay which is find out by there is 1 bit delay packet size upon bandwidth to find out the 1 bit delay time, and then again TP transmission delay. So to sum the total value, then we get end-to-end delay, means from host to destination how much time it take. Now here we come with hub. Hub is also a physical layer device and layer 1 devices. The multi-port repeater. In repeater there is only one incoming host, one incoming port and one outgoing port. When there is a multiple incoming and multiple outgoing port are available here in a device, that device is called hub. Simply in repeater there is only one incoming and outgoing port, but in hub there is a multiple incoming and outgoing port. That's we call it hub. But the hub is a repeater but having multiple port. Working same, it generates a signal into all connected links except the incoming link. If there is one incoming link and all are the outgoing links, then it generates the signal and transfer it into the all connected outgoing link or channel. it also create a 1 bit delay, or by 1 bit forwarding. In forwarding it create 1 bit delay. Here the example, we have the hub, and hub is connected with 4 bit of 4 nodes or 4 hosts. 4 hosts are connected with the help of hub, so they can make communication between all these network. Here the hybrid network, here hub is connected to 1 network, 2 network and 3 network. Hub is also used to connect 1 or 2 or more networks. Here the entire LAN has same broadcast domain. Means that if the A1 send the frame, then the frame is received by B, C, D, E, F and H and G. Means if the frame sent by A, then it travel from channel, for it received by B, C, and it sent through the hub generate it toward this network and this network also. So this network H or G also get the frame, and another network D, E, F, D, E also get the same frame. So there is a same domain, same broadcast domain received by the frame is received by all the nodes. If the frame is, if the destination, if the destination address is H, then H receive the frame, and if in a frame destination address is H and packet received by G, then packet read the host G read the packet. If there is a destination is not its own destination address, then it discard it. In the same manner, if the E receive the packet, check the destination address. If destination address is E destination address, then it will receive the packet and say that yes, it's my address. But if not, then discard the frame. Here the point is no collision domain separator. Means that if the A frame, if A nodes, A host send the packet, and if there is a collision happens between the channel, if the collision happens, then the collision signal is sent to the A, B, C and transferred by the hub to the G, H, E, D or F host also. Means if there is any collision, between in entire this given network, then if the collision in any type, if there is any collision in the given network, then the collision is notified or detected by all the nodes, because hub transfer the collision signal also to the all connected nodes. So one thing also, hub is called dumb device because it have no any logic. It only simply if incoming signal, then resonate it and transfer it to the connected nodes. They do not have any types of other logics or do any processing to the frame signal. Okay, here the collision domain, place where the collision can occur. Collision occur in any network, identify the all connected nodes. As we know here, it is not a collision domain separator, but how is it not a collision domain separator? Means that if there is a collision in any network, it is notified by the all other connected networks. If collision happens here, and the collision is detected by all other nodes. If the collision happens in this network, the information that the collision happens is notified by all other nodes. Okay. Now the switch. In data link layer, it's a layer 2 device called switch. The old name of switch is also called bridge or bridge, or it's called, and we say that bridge is a single port, means bridge is switch. Switch is a single port device, and switch is a multi-port device or multi-port bridge. Single 2 port two-port device called bridge and multi-port device called switch. It is also a store and forward device. It store the frame, process it and forward it. It can store and forward it. It has switching table called forwarding table based on MAC address. Here the switch have switching table which is based on MAC address of destination MAC address. Having intelligence. The switch is a switch device which having some intelligence. They are not a dumb device. As you know, the types of switches. Here are the two types of switches, static and dynamic. Static switches are, in past years, the static switches are used, but they are non-adaptive and manual updated. In switches, we have to manually create the switching table and update it. If we want to connect new nodes, then we have to manually update their MAC address and configure the switch into the switches. It's called static types of. In dynamic types of switch, it is already adaptive, self-learning and plug and play. Means in adaptive type of switches, if there is a switch and we have to connect the one node or host to the switch, then we will connect and the switch send the signal to the host and get the MAC address. If we connect the host and here there is a switch, and now we can transfer the packet for the frame through the switch. Don't need to be manually update the MAC address in the switching table. It will auto add MAC address into the switching table. This newly connected host MAC address into switch table. Auto don't need to be add manually. It is self-learning, and if we remove the host, then switch itself update the switching table by removing the old or previously connected host device. Means that here don't need to be a manually updation of the update or delete the MAC address or switching table. Now here we see there is a switch and there is a 4 nodes are connected with switch. Now here the most important part is switching table. The first host and the frames, the MAC address added into table. Here in the switching table there are 3 columns, MAC address, interface and TTL. In MAC address there is a host MAC address of the device connected devices, and their interface means their port number, in which port they are connected with the switch, and the TTL, at what time we have to delete the entries. Okay, in switching table there are 2 values, already default value. Here the default value, the interface is the broadcast media, and here this is the broadcast MAC address. It is the broadcast MAC address as we taught in previous videos. Means these 2 are the default entries, and there is some connected nodes MAC address. Means a total n+2. n+2 entries are here in switching table, and is the number of nodes connected with the switch. Okay, here the diagram. Here the one switch connected with different networks. Here are 2 different network bus topology networks are connected with the switch. Here let the MAC address host a MAC address. Okay, let's take example to understand how the switches and communication between the switches work. Let host A send the packet to the D. Host D want to send the packet to the host D. Then it send the packet here, send the packet into the channel, and here the host D get the frame and check, yes, destination address is my, then it accept it. It's my packet which is sent by the host A. Now here if some frames go through the switch, when the switch get the packet, process it and check the destination host. Means if the switch get the frame, then it check the source address. If source MAC address is check the source MAC address, yes, source MAC address. If the source MAC address is not in a switching table, then it add the source and MAC address and its port number, in which port the frames come, then it create entry of the source host. Now again it check the destination address, destination MAC address. If the destination MAC address is in its switching table, then checks the interface. If the destination happens from another interface, then it transfer that frame into that interface or in that port. But in case here the MAC address is coming from the same home port, means that here the port 1, the host MAC address is connected with port 1, and the receiver's MAC address or receiver device is in same network or in port 1. So when the switches see that the host and destination are of same network, so that it decide need not to transfer the frame into another network, because the frame belonging to the same network. So here the switches stop the frame forwarding. It will not forward the frame to the another network, because he know that the frame is belonging to the same network. Okay. Now in second case, if the host A want to send the frame to host J. Now here the frame A. Now here frame A send the frame into the channel, and here the frame received by the switch receive check. The source MAC address is A, okay. Destination MAC address is J, which is in its switching table. The interface is means different, means here the frame is coming from port 1 and transferring to the and destination host belong to port 3. Now here the switching do selectively forwarding, means here the switch forward frame from one network to network 3, means port 1 to port 3, not send the frame to port 2 because the destination MAC address belong to port 3. So it not transfer frame into the network 2 via port 2. It transfer the frame into the port 3 where the destination MAC address belong. So here selectively forwarding happens. Now in case 3, if A want to send the frame to all the nodes, connected nodes, then if they send the packet, it send the frame, then the switch check the source MAC address, okay, source MAC address A, then check the destination MAC address. If the destination MAC address is not, because here the destination is not single host, the destination is all connected nodes. So in case of all connected nodes, it is a broadcast. For broadcast, destination address is this destination address used if you want to send the frame to not a specific host, we want to send the for all connected host, we use broadcast MAC address, and this is a broadcast MAC address. If in destinations MAC address there is a broadcast MAC address, then it will transfer the frames into all connected ports. Means that if there is a destination MAC address is broadcast address, then it forward the frames into all connected nodes. Means the frame is transferred to this network, and frame is transferred to this network also. Not a specific forwarding, not selective forwarding happens here. Okay, got it? Here all three cases. Okay, now in here the entire LAN have same broadcast domain. Means that if the any one of them nodes want to broadcast the frame, broadcast means want to send the frame to all the connected nodes, that it can broadcast it and switch transfer this packet to all the connected networks, and from network they get the packets to the node. Packets get in the channel and nodes receive that packet. Broadcast to all host of the networks. Collision domain separator. It is a collision domain separator. And previous we know hub is not a collision domain separator, but here the switch is a collision domain separator. Means that if A want to send the frame, and if the collision happens here, now the message of collision is received by the B, C and D. But if the collision error message, collision error message, collision signal is received by the switch, but switch won't forward or do not forward the collision signal into the other connected network. The same thing happens if the collision happens in this network. The switch won't forward the collision signal into the another connected network. So there is a collision domain separator. So the switch can also be a collision domain separator. Means the collision is happens in any one of the network, that it will not be forward to the another connected network. Now here, to connect different types of LAN segment, minimum 2 layer devices are required. To connect 2 LAN segment, minimum 2 network layer devices required. Here there are 2 types of topologies: bus topology and ring topology. 2 types of network segment. To connect these 2 types of network segment, we can use at least 2 layered network devices, layer 2 network devices. We can't do this with layer 1. We can't do it with layer 1 network devices. At least layer 2 network devices are required to connect 2 different networks. Okay. Now here the spanning tree protocol, STP. If there is a multiple switches inside the network, may form a circular loop. See here, there is a switch 1, switch 2, switch 3, switch 4. These all switches are connected to each other, and from these switches there is a multiple nodes. Okay. To avoid the infinite transversing of the frame, switches uses spanning tree protocol. To avoid the frame looping of the frame, to avoid the looping of the frame, we use spanning tree protocol. What is infinite looping of the frames? Means that if frame S, okay, if the node want to send the frame, it send the frame, then switches S forward the frame toward the S, another switch. If there is any MAC address, if there is no any host having a destination MAC address, which is the MAC address on the frame, then it will transfer it to another switch. Then same thing, if there is no any MAC address match with the frame's destination MAC address, then it again transfer it. If there is not any other MAC address, it is MAC address which is a receiver's frame MAC address, frame destination MAC address, then it will again transfer it. If this thing happens in round and round again and again, to avoid this looping, we use a spanning tree protocol. Okay, thank you.